Hello everyone, welcome to Chaudhary Data World channel. Today I am here with a new video in the Pandas series, that is indexing in Pandas. This is going to be the third part of the video of data selection and indexing with Pandas. We'll be watching all the details regarding indexing available into Pandas. So let's get started with the video. Before moving ahead with this third part of this video, let me tell you what learning roadmap we are following. So this is the learning roadmap in which we have covered up data import, data exploration, data cleaning, and this was right now we are dealing up with data selection and indexing. In this data selection and indexing, this is going to be the third video. I have already covered up two videos, or you may say two part of the video, into which I have covered up data selection and then other stuffs, whatever filtration technique and all we are having. This is where we will be mostly talking about indexing. So what indexing is nothing but it's, you may say, you can visualize, or in layman term you can understand it something like that. Only filtration is, in other way it is told as indexing. That means selection of subset of any subset from any particular specific data set, it is only called as indexing. Or better to understand, suppose if you are having you can visualize like this. If you are having a book, into that book you are having several pages, right? In against those several pages there is an index page related to that particular one. So that only thing it is over here, that against each of the row into the data set we will provide some index. That is only called as indexing. How it will benefit? It will benefit in performance. It will be make the data retrieval very fast. But the disadvantage is also there of indexing. The disadvantage is that your query will become very complex. Also, the second disadvantage, that memory usage will definitely become high, because you are now creating your index on the basis on that particular data set. So these two things which was to be kept in mind, the advantage and the disadvantage. Now moving ahead, so you can see that the common ways of indexing, those common ways are only which I have covered up in earlier videos. Those are label based indexing, position based indexing. So this dot lock I have already covered up in those two videos. So this dot lock is also called as label based indexing if you are calling in terms of indexing then. And the functionality remains same, whatever it was there, it is same as on both of the places. So that label based indexing also I have covered up. Then position based indexing, so that is iLock. iLock I have already covered up. So this iLock is, in indexing term, it is called as position based indexing. Then we are having Boolean indexing. Boolean indexing also we have covered up, into which I have told you that how to create any Boolean filter. You can see over here, you can see that into our Boolean mask it was there, right? Boolean mask. So this is something which is called as Boolean indexing only. So this I have already covered up into the filtration techniques. Yet I will also cover up this these topics right now in clear demonstration, but I am just jumping to multi-level indexing, because this is something which is going to be a new into this video, that is multi-level indexing. Now multi-level indexing is something which you can provide any particular data set. Suppose you are having a data set with multiple rows, you can provide two indexes or more than two indexes to that particular data set. What I am going to tell you, so let me show you what I am trying to tell you. So let's jump to this one, and over there you can see now I will just directly jump to multi-level indexing. What you can see over here, that what we are creating multi-level data frame first. Data frame is nothing but the Titanic data set. On the Titanic data set we are setting up the index. Now what indexes we are setting up? We are setting up indexes that are two columns, sex and then class. So that is creating our multi-level data frame. Now till here, if you are not sure that what we have done, we can just do the multi-level index. We will first apply now multi-level index on top of that particular data frame. So this is the data frame, correct? This is the data frame on which we will apply the lock, and lock with female and then first. Now what we are going to do, we are going to see the data set now after indexing. How does it look? So as soon as we execute it, what you can see now, that we are having a proper data set. Into that proper data set we are having, you can see here that we are having all the columns, survived, P class, age, all these things are there. Apart from that, we are not having any row number. Now instead of row number, we are having indexes, and that indexes are basically two indexes over here, sex and class, correct? So sex is the first index and class is the second index. Into that sex, you can see that we are just filtering female. If we will not filter female, what it is going to be? Let's try out. So you can see that now, since it was, if we were filtering, it is right now 94 rows, 13 columns, correct? And if we are commenting it out, then also we are getting 94 rows, 13 column. So what it is trying to tell you, that you are going to get these two level indexes, sex and class, into which there will be this particular one, index at the first, because it will first cover up female thing, correct? Now this female thing, if it is covering up into the sex, there are two types of sex here into our data set, that is female and male. So first it is female covering up. Into that female we are having all the first at first glance, and then we will be having the class second or the third, whatever available into the data set. And basis of that, whatever the column value it is becoming, it is covering up over here into the data set. So hope you are getting that how indexes are getting created into our whole of the data set. Fine. Now moving ahead, if suppose this was how we can create the multi-level index. Now we are having a different concept of dot access. Dot access is a function which is called as cross selection function, which basically deals up into this multi-level index. When you want to retrieve the data from that, right now what we created our whole of the data set, fine, and data set along with your index. Now what if you want to retrieve the data with dot access method? We are having dot access method which is called as cross selection, which is used to select data at a particular level of a multi-level index. So basically, let me tell you that this particular one, whatever you are seeing right now, it is having the levels, right? That first level of indexing is sex, second level of indexing is class. So on what level you want to do indexing, on what level you want to retrieve the data, this better you will understand when I will demonstrate you. So let's go ahead with the dot access cross method demonstration, into which what we are going to do is, we are going to create a data frame. Why I am creating explicitly a new data frame? Because that particular data frame which we were using, Titanic data frame, was very much complex and you will not be able to get what it is trying to tell. So what I'm doing, I'm creating a very small and very simple data set first. Into that you can see that we are having data as, into which there is key as value, and its values are in the list, that are 10, 20, 30, 40, 50 and 60. Now we are going to create an index, and that is going to a very complex index we are going to create. You can see after creating index how the data is looking. We are having a category index first. Into that category we are having A, B and C. Then we are having subcategory, into which we are having X and Y. So for A you can see that X and Y is present into the data set. In B there is no Y, only X is there. In C you can see over here that there is only Y over there. After that, at third level, what it is going to be, the subcategory, correct? subcategory, not subcategory, subcategory. Into that subcategory, what you can see, for A category and subcategory X, we are having subcategory as 1 and 2. Again, for category A and subcategory Y, we are having this subcategory 1 only, not other than 1, only it is 1 over here. Then for the subcategory B, we are having subcategory X only present into our whole data set, and against that at X we are having subcategory as 2. Correct? Now again we are having next level of indexing, that is on the basis of label, and the labels are for the A, X and then 1 we are having alpha. For again A, X and 2 we are having beta. Again we are having A, Y and 1 we are having. So these are multiple permutation combination of indexes going on over here, and at the last we are having the value column, which is going to be your column. These were your indexes, correct? Category, subcategory, subcategory and label were your indexes, and this value is going to be your column. Now this value is going to be mapped basis of those indexes. So there are multiple indexes but only one column. Hope you are getting the point how indexes is getting created. Now the very confusing part into which everybody gets confused, that what if suppose we want to provide label, because if you will see the syntax of dot access, here you can see that we need to provide first key, then axis, then level, then drop level. So the very required parameter is only this key one. After that, this axis, level and drop level, if you want to explicitly tell it, then it will work. Otherwise, at least key will be needed. Rest of the things, it can be optional. But suppose what if we want to retrieve with the optional parameters? So here we will see how we can have retrievable basis of label, basis of key, all the combinations we will be seeing it out. So I am telling you these all in detail because this is going to be a very confusing topic. If you are going on the internet and searching a lot, definitely you will be confused, because at many places there are multiple examples, but the explanation is not that much. What I felt is not that much at that point. So let me tell you how we can do it and how we can break down all the concept of this key and level at granular you may say level. So here you can see that if you want to retrieve the categorical data, correct? So for retrieve the categorical data, we are having df.access, that is for sure. In this you must not having any confusion. Now the key will be A, because we want to retrieve only this particular category. If we are hovering over it, you can see that A category is having the access of this particular data, A, X and then alpha, correct? So what is doing, it will retrieve this much data if we are telling it this much data, which is highlighted right now, because into category A this much data is falling, correct? So you can see over here that when we are retrieving in the basis of A, we are having X and Y, correct? Subcategory has an XY, which is highlighted over in the above, and then the three things 1, 2 and then 1. This is going to be subcategory. Then your label, which is highlighted over here, you can see clearly, right, that from A these many things can be extracted out, and the value as 10, 20, 30. Now what if we and here you can see that we are having another parameter, that is level equals to 0. So level equals to 0 by default, it is over there into the pandas. If you will not even provide it, it is going to work then as well. But why I have declared it here, just to demonstrate that the outermost hierarchy, what it is going here, hierarchy creation is going over here. First hierarchy category, hierarchy of category, then there is subcategory, then subcategory, like this, then level. So at the very outermost hierarchy we are, so for the outermost hierarchy there is level equals to 0. Now what if I am moving one hierarchy inside of whole of the hierarchy circle? So what we are going to put key as X, correct? So in the original data frame, after category, what you can see subcategory, and for subcategory what all values are there? X and Y. So we are going to choose X. This time if we will not provide label, hopefully it should throw you error. Why it is throwing you key error? Because it is not able to understand that at what level this X is. It is searching this X on the level of 0. Now level of 0 is containing category, not the subcategory, category with the values A, B and C, not the X, Y, correct? So you need to explicitly tell it that it is on the level of 1. Level of 1 is telling you that you are one level deeper of your level equals to 0. Now once you do it, you can get over here that inside that X definitely these many things were there, correct? These many things were there. So which is getting where it is. So these many things were there for the you may say category A, because you are filtering on the basis of X, correct? And category is over there A, and there is also a category B. For the B category, what you can see, X is there, and for X 2 delta and 40 is there, right? So it is retrieving that values as well, because in X all these things will fall, right? Then similarly I don't think that now there is much explanation needed. For level 2, suppose we are moving one level more deeper, that is after category subcategory we are having what? We are having subcategory. Now this subcategory we are putting it over here as key, and inside that key definitely it will not again understand, so we explicitly need to tell that we are on the level of 2, and then when you are going to execute it, you are going to get this, correct? Now the question comes that here we are having another set of, you may say, parameter, that is drop level equals to true. So by default drop level is equals to true only into your whole of the whatever your syntaxes you are running it right now. Now what if you want to drop level equals to false? So what it will become? It will become that suppose subcategory underscore data, it is right now this one. Again you are creating means you are retrieving with some other index in this particular variable, but if you defines drop level equals to false, then it will change the original data frame whatever it was having over here. It will change this data frame only to wherever you are putting drop level equals to false. That means whatever the result will be, that result only will become your original data frame then. Hope you got this concept. In general scenarios, you are not going to use this particular parameter which I am right now making you understand this drop level, but this is what it is for. Okay, now at last I am just showing you axis. The another thing we are having is axis equals to 0. In each of them, whatever we saw right now, in each of them axis was equals to 0 by default. Now what if we want to make axis equals to 1? So I have taken up an example into which we are going to see axis equals to 1. So for that, what we are going to do, we are going to create a new data frame. Into that data frame, this is again a very basic data frame into which you can see over here that we are having indexes created on the column level as well, that is on sales we are having January, and inside that January we are having product A and product B. Again it may happen that in the sales column we are having another index that is Feb, and inside that Feb there might be product A and product B, right? So in this particular scenario, we are having only month of Jan, into which we are having product A and product B. Now if we want to take up this product A index, because we are creating the index on the basis of row also, and we here you can see that we have created on the basis of column as well. That is, first label is sales, then we are having months, that is Jan, Feb, March, April, whatever, then we are having the product. So what if we are taking product? So product we have taken up, level is equals to 2. Level is equals to 2. Why it is 2? Because sales was the 0th level, Jan was the first level, and product A and product B is going to be your level 2. That's why we are taking up level 2. But since axis is equals to 0 at by default, so you need to specifically tell it that axis is equals to 1. Why 1? Because this is into the column based index, correct? That's why axis equals, whenever we are dealing up with in the scenario of column indexing, definitely it is going to help you, and help you not, it's mandate that you need to provide axis equals to 1. Then only it will understand that we need to apply all the filters whatever you are putting up into your axis parameter, it is going to be applied over there. So this is what it is all about. This is what it is all about, your multi-level indexing, then your cross selection, that is access, and these all things, those are only the previous things only. That lock I have already explained you that how lock is working. I have just summarized it up over here, that lock is for the function is used for the labels. When you want to provide the level based, you need to retrieve the level based things, definitely you will provide lock. If you want to retrieve the positional based thing, definitely you need to provide iLock. So this is what all about this whole video, and with this it is going to end up with this particular topic, that is data selection and indexing with pandas. Hope you got all the concepts very clearly, and if any confusion, let me know into the comment section. Thank you so much guys for watching out the full video, and see you in the next one with some other topic. Stay tuned to the channel. Till then, thanks again.